Imagine sitting at your desk, hands completely off the keyboard, watching your cursor move with eerie precision. It's not a ghost, and it's not a pre-programmed macro. It is an AI navigating your actual desktop environment, clicking buttons and filing reports just like a human would. This is the reality of the OpenClaw framework. While we've spent the last 2 years chatting with boxes on a screen, the engineers behind this tech were building something far more ambitious. They were building a way for AI to finally break out of the chat box, and the way they're doing it is genuinely brilliant. It represents a fundamental shift from large language models to what researchers call large action models. It's the difference between an AI that can tell you how to book a flight and one that actually buys the ticket. OpenAI's acquisition of the team and tech behind OpenClaw wasn't just a talent grab. It was a strategic move to secure the personal agent future. They realized that for AI to be truly useful, it needs to understand the software we use every single day. Think about your workflow. You jump between Slack, Excel, and custom internal tools that don't have fancy APIs. Most AIs are blind to these, but OpenClaw was designed specifically to bridge that gap by seeing the screen exactly as you do. This isn't just an upgrade, it's a new species of software. And to understand why OpenAI spent so much to get it, we have to look at the numbers and the sheer technical difficulty of what they've achieved.
The core problem with current AI is the API wall. If an app doesn't have a public interface for the AI to talk to, the AI is stuck. OpenClaw ignores the wall entirely. It treats the graphical user interface, the GUI, as its primary playground. By interpreting visual elements in real time, it can navigate software that hasn't been updated in a decade. This is why it's being hailed as the successor to standard LLMs. It's the first step toward a truly autonomous digital assistant. But here's the part nobody's talking about. How does it actually see a button? How does it know that a blue rectangle is a submit button and not just a decorative box? That's where the technical architecture gets wild.
To the OpenClaw framework, your screen is just a massive matrix of pixels, but through a process called semantic UI parsing, it converts those pixels into a structured tree of actionable items. It's like the AI is building a mental map of your desktop every few milliseconds. This isn't just a screenshot, it's a deep understanding of hierarchy. It knows that the Save button belongs to the File menu, even if that menu is currently hidden. This spatial awareness is what separates it from simple screen scrapers. And that leads us to the most fascinating part of the whole system, the GUI navigation pipeline. This is the engine that allows the agent to move from thinking to doing without a single human intervention. Now, you might be thinking, is this just a fancy version of remote desktop? Not even close. OpenClaw doesn't just mirror a screen, it interprets the intent behind the software's design. It's a bridge between human design and machine execution. But to truly appreciate the engineering here, we need to dive into the pipeline itself. We need to see how it handles the chaos of a real-world computer, the pop-ups, the slow loading times, and the accidental clicks. Because as we're about to see, the way OpenClaw handles visual noise is one of the most impressive engineering feats in the history of AI. Let's break down the pipeline. The GUI navigation pipeline starts with the eye, but it's not just taking a picture, it's performing high-frequency screen sampling. We're talking about the AI observing your screen at rates that allow it to react to animations and transitions in real time. Every frame is passed through a vision transformer, or VIT. This model doesn't just see colors, it identifies the boundaries of every window and the exact coordinates of every clickable element. It's turning a messy desktop into a clean coordinate system. But here's the clever part. Instead of just looking at the current frame, it looks at the history of frames. It understands that a button turning gray means it's been clicked. It understands the flow of time within the interface. Once the eye has mapped the screen, the brain takes over for visual parsing. This is where OpenClaw uses a specialized neural network to label every element. It's basically a massive real-time game of I Spy, but with 99% accuracy. It identifies affordances, the things you can actually do with an object. It knows a slider can be dragged and a text box can be typed in. This semantic layer is what allows the AI to plan complex multi-step actions. Think of it like this. If an LLM is a master of words, OpenClaw is a master of digital geometry. It understands the language of the interface, the spacing, the alignment, and the visual cues we humans take for granted. Now we get to the action space. This is how the AI actually interacts with the OS. It doesn't move a physical mouse, obviously. It sends low-level system events directly to the operating system's input queue. It's basically teleporting clicks to the right coordinates. But it's not just clicking blindly. The pipeline includes a verification step.
After every action, the AI checks the screen to see if the expected result happened. If it clicked submit and the page didn't change, it knows something went wrong. This feedback loop is what makes OpenClaw so reliable. It's not just firing and forgetting, it's observing, acting, and verifying in a continuous cycle that looks remarkably like human behavior. One of the biggest hurdles for this tech is non-API software. These are the legacy apps, the custom tools, and the clunky interfaces that don't play nice with modern code. For a standard AI, these are invisible. For OpenClaw, they are just another set of pixels. This allows the agent to manage professional workflows that were previously impossible to automate. Imagine an AI that can log into your company's 20-year-old accounting software, extract data, and then paste it into a modern CRM like Salesforce. It's the ultimate glue for the digital world. It doesn't need the software to change. It just adapts to the software that already exists. And that is exactly why OpenAI saw this as a game changer. But there's a catch. Navigating a GUI is incredibly noisy. A random notification, a flickering ad, or a slow-loading spinner can confuse a basic model. OpenClaw uses a contextual attention mechanism to filter out this noise. It prioritizes the elements that are relevant to the current goal and ignores the rest. It's the digital equivalent of tunnel vision, but in a good way. It keeps the agent focused on the task at hand, no matter how messy the desktop gets. This technical foundation is what allows for the action observation loop, the heartbeat of the personal agent. And as we're about to see, this loop is what changes everything for professional productivity.
The true aha moment of OpenClaw is the action observation loop. Think of it as the AI's central nervous system. It's a continuous cycle. Observe the screen, decide on an action, execute that action, and then immediately observe the result. This loop happens several times per second. If the AI types a character and it doesn't appear in the text box, the observation phase catches the error instantly, and the action phase tries again. It's self-correcting by design. This is what allows an AI to manage professional workflows autonomously. It doesn't just guess what to do, it lives in a constant state of checking its own work against the reality of the screen. One of the most important aspects of this architecture is that it can run on a local machine. Because the agent needs to see your screen, privacy is a massive concern. OpenAI has designed this to process the visual data locally, only sending high-level intent to the cloud. This means your sensitive emails, bank statements, and private documents stay on your hardware. The AI understands them to perform the task, but the actual pixels never leave your machine. It's a clever solution to the Big Brother problem. And because it's local, the latency is incredibly low. The agent can react to a pop-up in milliseconds, making the interaction feel fluid and natural, rather than laggy and robotic.